Hi, this is Dan Brunton with the Intel Corporation, and this is the first of 3 videos where I'm going to be doing an in-depth conversation on working with Intel Endpoint Management Assistant and Intel Active Management Technology. In this first video, we're going to start with an overview of how Intel AMT works and what it is if you're not familiar with it. We'll talk about provisioning models for working with Intel AMT and Intel Endpoint Management Assistant, and finish off with some networking considerations. There's a few expectations for this video series. First, that you have an Intel EMA environment set up that you can work with. Second, that you've got some experience in that environment navigating the application and the user interface. And third, that you've reviewed our Intel EMA documentation. With that, let's begin. We're going to start out with an overview of Intel Active Management Technology in case you're not familiar with it. So Intel Active Management Technology, or Intel AMT, is a hardware capability in the Intel vPro platform that lets you take control and save time and money in managing devices. So when we say take control, we give you the ability to remotely manage devices at a hardware level over wired and wireless networks. The idea being that you can avoid potential problems by taking advantage of our power control, for instance, to be able to bring systems online so you can do updates to software operating systems. You can also solve problems that you have to deal with in a little more efficient manner by using our capabilities like KVM remote control to reduce the number of on-site visits you have to make, because you can basically reach out and work with that system just like you were there in front of it. And one thing I'd also like to point out is that Intel Endpoint Management Assistant supports AMT versions 11 and above, and that coincides to our 6th gen core vPro platform and later. Next, I'd like to talk about what we mean by out-of-band management with Intel Active Management Technology. In this case, out-of-band means without relying on the operating system. So when we go to use our management technology, we use it all inside the chipset. So if you look at the larger diagram here, you'll see that management traffic comes in from the network, goes into the chipset through the wired network interface, where it hits our Intel management engine that runs Intel Active Management Technology. So all the management traffic stays there in the chipset, and the balance of the traffic goes to the OS. With wireless network interfaces, it works a little bit different, because either AMT gets to own the wireless network interface or the operating system does. They don't share it in the same way that they do with Ethernet. So in the case where the operating system is online and using the wireless network interface, management traffic will actually pass through the operating system into Intel AMT. However, if you're working with wireless and the operating system is offline or not functioning correctly, in that case, Intel AMT will take over ownership of the wireless interface. It'll get it back onto the Wi-Fi network itself, and then all that management traffic will again come in through the wireless network directly into the chipset, allowing you to manage that wireless device without actually having to have a functioning OS. Next, I'd like to talk about some of the Intel AMT use cases we have as of this video here. Now, this is not an exhaustive list, but this has some of the most popular ones. So here in the top row, we can see 3 great use cases. First, remote power control, and that's the ability to send power on, power off, sleep, hibernate, even send a command to a system to tell it to reboot into BIOS. We also have our hardware alarm clock, and that's there to give you the ability to turn systems on at a predetermined time without having to send interactive wake commands to them. And third, our hardware KVM remote control. This gives you the ability to see exactly what's happening on that system remotely, again, even without the operating system being in a functioning state. An example here would be that you could use a tool like this to go through and help an end user with a, say, full disk encryption problem. If you're using some type of disk encryption software and they're having trouble unlocking the drive, our hardware KVM remote control gives you the ability to see that and deal with that kind of problem, again, remotely without having to visit the system. Now, what's new with Intel EMA is beyond the firewall support and cloud-based manageability. So we give you the ability now to work with devices through firewalls, through proxy servers, as well as install the Intel EMA software in the cloud so you can manage devices across multiple networks. This can be very handy for companies that have a lot of people that work from home. And ultimately, this brings you to the last 2 items we have here. It gives you a great platform for unattended system control. So if you think about managing devices such as digital signage that, say, may be located on the side of a road, we now have a solution here that allows you to easily manage those devices at a hardware level without sending out a technician. And another great use case, too, is around upgrade management. We live in a world today where Windows gets updated on a fairly regular basis. And if you've had trouble in the past where you've had to send technicians or have people bring PCs in to manage this upgrade process, you now have an option of being able to monitor that upgrade management process completely remotely, again, at a hardware level. Next, I'd like to talk about the supported network interfaces for working with Intel AMT. Intel AMT works with the built-in Wi-Fi or Ethernet devices that come on your Intel vPro systems. We do also support docking stations if they have an electrical pass-through for the Intel Ethernet that's on the laptop. However, we do not support USB Ethernet adapters, USB Wi-Fi adapters, USB docking stations with their own built-in Ethernet, Thunderbolt docks, or discrete devices at this time. If you do have an environment where you're using, say, Thunderbolt docks or have to use USB adapters as part of your solution, we recommend that you leave the Wi-Fi interface enabled on those systems when they're docked and using Ethernet as well, so that you can send management commands over Wi-Fi to give you the advantage of out of band, but still give you the flexibility to dock those systems. All right, next let's move on to talking about the provisioning models for Intel AMT and Intel EMA. We're going to start out by talking about the two ways that you can enable the configuration process for AMT. We support both an automatic configuration as well as a manual process. With automatic configuration, you go through and predefine an Intel AMT profile that'll be used to configure Intel AMT on your vPro devices every time they become members of a new endpoint group inside of Intel EMA. This particular configuration supports 802.1x, as well as the ability to predefine Intel AMT wireless profiles. Now with manual provisioning, you have to go through and tell each system independently one by one that you want to turn on AMT and configure it on that device. And this does a very basic configuration. It does not include support for 802.1x authentication. It's really designed for debugging purposes. And again, contrasting the two, for instance, with Wi-Fi profiles in manual provisioning, you have to go through after you've configured AMT on that system, and as a secondary step, manually add in Wi-Fi profiles that you may want Intel AMT to use. Now, for provisioning models with Intel AMT and Intel EMA, we have two models you can work with. Those of you who have been working with AMT in the past with some of our other solutions will be familiar with TLS provisioning. This is a model where you configure AMT, and AMT on each device sits and waits for commands to be sent to it. So this is where you would send it power commands. You'd, from an admin console, initiate a connection to that PC to remote control it. The communication is encrypted with TLS certificates. And one of the biggest advantages for TLS provisioning, it allows interoperability with standalone or on-prem tools. So for instance, if you've been using the vPro PowerShell module to automate things in your environment, TLS provisioning would allow you to continue to use that same set of PowerShell scripts to manage AMT on those devices. And again, it's really designed for an on-prem, behind-the-firewall type usage model. So our other provisioning model, Client Initiator Remote Access, is really designed for cloud-based manageability. The difference between this and TLS provisioning is that Intel AMT establishes a connection to the Intel EMA server, hence the name Client Initiated. So instead of having to wait for the server to reach out to the AMT device, it establishes a persistent encrypted connection and uses that for management. And that's done to support cloud-based management, and we're going to be talking about that more here in an upcoming slide. Now, digging a little deeper with Intel EMA and TLS provisioning, there's a few things you need to keep in mind when you use this particular provisioning model. First, you need to have at least two computers on the same subnet for this to work. And that's because, number two, we pass the management traffic from one computer on that network to another. The idea being that you could have an Intel EMA server that's in the cloud that does not have direct access to the network that the devices are on, and therefore cannot send those direct commands to AMT. Therefore, we pass the traffic through another Intel EMA device on that same network, and it's actually using the Intel EMA software agent to enable that communication. And because of this architecture, we have to take into consideration the third point here. The moving between wired and wireless networks can cause some temporary interruptions. When you move Intel EMA devices from one network to another, all the peers on that network have to rediscover the devices around them so they can have that ability to route management traffic like we talked about in the second point here. And there may be some delays in that process taking place due to things such as DNS propagation. Next, let's talk about client-initiated remote access and why it's needed for cloud-based manageability. Well, it's here to really solve two problems. First, it provides a secure channel for sending those management commands back and forth over the internet. And we do this with a mutual TLS connection where each end of the connection is mutually authenticated by both the client device and the Intel EMA server. It also provides a mechanism for finding clients to manage. One of the challenges you have in a modern cloud environment is that if you have somebody working from home, their PC is going to be behind a firewall, and there's going to be no way for Intel EMA to find that device because the firewall will block it. So by having the device reach out to the Intel EMA server, it makes it very easy to work in distributed cloud environments such as the internet. All right, I'd like to move on to talking about some of the networking considerations you need to keep in mind when working with Intel EMA and devices over the internet. So if you want to manage devices through the cloud, Intel EMA has to have known networks to work with. And there's really two things that make up what a known network is in this case. First, it's a network that has access to the internet. And we can work with networks that have NAT-based firewalls or proxy servers in place. If you are working with certain proxy architectures, you may have to have AMT version 12 or later to work with those. We also have considerations around authentication. So we need to have networks that Intel AMT can authenticate with. In the case of Wi-Fi networks, this would be open networks with no security. 802.1x networks if you're using enterprise-grade security, or networks that use pre-shared keys. And with wired networks, it's a very similar type of thing. We support traditional unsecured networks where you just plug your Ethernet cable in and everything works, or 802.1x secured wired environments as well. When we think about Intel EMA in the cloud, there are some scenarios that can be a little more difficult to support. I want to talk about those now. Most of these are going to flow around Wi-Fi type usage models. So let's start out with supported scenarios. So if you think about traditional office spaces, co-working spaces, home offices, if you have any environment where Wi-Fi access does not require you to accept any terms and conditions to connect with the network, you'll be good to go. And we have a couple of options, again, that we'll talk about here with working with wireless profiles that allow you to synchronize them or pre-configure them for these kind of environments. Now, when we think of IoT and embedded type usages such as digital signage, Intel Unite hubs, devices that may not have a person in front of them or may in fact be remote, like we said, even with digital signage, perhaps alongside a road, there's a couple of options for working with these kind of devices. First, if there's some type of on-prem internet available, you can use that. In the case where on-prem internet is not available, we recommend using a cellular to Ethernet or Wi-Fi bridge, so you can use a cellular network as your backhaul to be able to manage this device, but still present Ethernet or Wi-Fi so that Intel AMT can communicate with it. Now when we think about difficult to support scenarios, hotels, coffee shops, airports, those kind of environments are typically what come to mind. It's really any place that you have to accept terms and conditions to get onto Wi-Fi or perhaps even supply a credit card to pay. Now, if you've had a chance to synchronize a Wi-Fi profile, you may be able to get AMT onto these networks. However, if you think about a use case like this, where somebody's traveling and has a problem with their computer while sitting on an airplane, where they get off the plane and think, I'll use the airport Wi-Fi to allow IT to fix the problem. If you've got no way to open up a web browser and authenticate and accept those terms and conditions, AMT won't be able to get on. So the workaround for these kind of use cases would be to use a pre-configured hotspot. So for instance, on my cell phone, I could have my hotspot pre-configured to work with Intel AMT. So if I do have a problem, I can kick on the hotspot and my IT department can use that to make use of Intel EMA, Intel AMT, and resolve my problem remotely. And finally, for laptops that are turned off and not connected to AC power, we don't have Intel AMT run on those systems. And that's for a couple of reasons. First, we don't want to have any thermal issues of trying to open up applications while a laptop is in a bag and may overheat. And the second is we don't want to drain somebody's battery when they don't expect it to drain. So in cases like this, when you think about the ability to wake and patch a system, they don't work again if the laptop is off, hibernating, and not connected to AC power. We mentioned Wi-Fi networks, and I wanted to talk about that a little more. So when you configure Intel AMT, you have the option of providing a configuration profile with some pre-configured Wi-Fi networks. So when you use pre-configured Wi-Fi networks, you can support both pre-shared key models and 802.1x authentication, and you can set up to 16 of these profiles in total. We also support syncing Wi-Fi profiles from the host into Intel AMT. So anytime your system connects to a new Wi-Fi profile, we can synchronize those settings inside AMT automatically. Now this mode only supports pre-shared keys. It does not support 802.1x and can hold a total of 8 of these synchronized profiles. And if a 9th network is joined, then the oldest profile will get kicked out in favor of the new one. Well, that does it for this video. Thank you for watching, and I look forward to talking with you more about Intel AMT and Intel EMA.